So the first panel has titled Archetypes in Art and in Mathematics. And we are welcoming first Professor Indira Chatterjee, who is a mathematician, also a science communicator, and she has developed some very interactive and very interesting platform about outreach and communication of mathematical concept and idea and geometric idea to the general public. I'm following here the alphabetical order, okay, which, so just you know that it's not any special preference. Then Valérie Félix, who is an art historian. She's also herself an artist, a researcher and a curator of some exhibit, I mean, and promoting also various talent. Etienne Crahenbuhl, okay, he is a visual artist and a sculptor, and we'll talk more about when he will be here, which I hope it's soon. We have also Louis de Saussure, who is a linguist, but also a writer, a novelist, and a poet. And probably you're tired because we always say this, but about you. But de Saussure is also a famous linguist from Geneva in the 19th century, and he was your great-great-father, or?
He was great-uncle.
Great-uncle. Okay. All right, it's fantastic. We have Paul Turner, who is really both a mathematician and an artist, and he's actually one of the persons really involved in the SHAPE exhibit, and he's responsible for some of the beautiful things you see there. And myself, as I will try to moderate this debate. So before starting, a few words about the notion of archetype, but we don't want to really do philosophy here, but just to have a minimal background. So it's a word that has Greek etymology. So archi means the origin, and typos means, well, the type or the model. So a possible translation is original model or actually prototype, but it's certainly more fancy to use archetype than prototype, and prototype has too much of a industrial meaning, so we don't use this word. So concretely, an archetype refers to something like a fundamental form or a theme that reproduces itself, changing, but having some constant feature, and repeating itself through various cultural contexts. It is a recurring idea rooted in a collective unconscious mind that reappears, always changing, and it reappears in research, in artistic creation, in science, and also in mathematics. Just as a word of warning, it sounds very philosophical, but you can compare indeed archetype to Platonic's ideas, the idea of the sense of Plato, but it's very different indeed, in the sense that the idea of Plato are supposed to be purely metaphysical, outside of the world, and the archetype are really rooted in human culture and psyche. Just a few examples that I had in mind about archetypes in mathematics would be very simple objects like what is the point, the sphere, regular polyhedra, the Möbius strip, for instance, etc., etc. More abstract concept would be infinity, the opposition between discrete and continuous. There in philosophy you have the Zeno paradox, notions such as the dimension, symmetry, and repetition. And for mathematician, a word of warning here, you have much, much more complex and deeper idea of archetype that have been developed by people like René Thom, but also Grothendieck and Laforgue. And you can have a look at what they are trying to convey with the idea of archetype, but this is way too abstract for our discussion today. A few examples of archetype in art. So before we have the sphere, and I put the sphere again, you will understand maybe why. Something like the opposition between light and dark. Some pattern, such as the journey, the quest, the eternal cycle of life and death in poetry and literature. The symmetry and repetition that you see in mathematics and also in art. And the labyrinth, for instance, would be an archetype in my mind if you think of Kafka, The Castles, and this kind of novel this representation of the complexity of the world could be seen as an archetype, probably. Okay. So the general discussion is going to be around the role and significance of such archetype in research and creation. And so maybe some of the panelists will not actually really speak directly about archetypes, but they will develop some example of their activity and will put together things after that. So the first panelist will be Indira, thank you. And she's going to speak about balls. And she will explain what is balls and the difference for us mathematicians between a ball and a sphere. Balls that tiles certain spaces, which is an interesting notion, and she will explain it because a priori you cannot tile space with ordinary balls because they are too convex and they don't really fit each other to create a perfect tiling, and this is why we have this notion of the densest sphere packing and other research.